I'll introduce you. So good evening, everyone. Welcome to this month's Zoom lecture series. Our presenter today is Ben Oster. He's a guest curator at the Curtis Museum. He's currently helping us with our newest exhibit. It's upcoming, which is Ascending Innovation, the Evolution of Vertical Lift Technology. He's a flying qualities engineer at the Boeing Vertical Lift Division. He also serves as the acting manager for the system safety on the H-47, Chinook, as well as the MH-139 platforms. He's got nearly a decade of aerospace industry experience, and he's contributed to the programs of the H-47 Chinook, the V-22 Osprey, MH-139 Grey Wolf, the CV2 cargo air vehicle, which we'll be talking about today, the SB-1 Defiant, and the T-7A Red Hawk, 777X, as well as the Whisk Air Taxi. So a lot of really complicated machines. And his work focuses on the design and simulation of vertical lift aircraft, for which he has 4 patents currently pending. And he's also a graduate of Cornell University, so a local university with degrees in aerospace, as well as mechanical engineering. And very excited for you to talk about our newest acquisition here at the museum. All right, Ben, you can take it away.
Awesome. Well, thank you, Andre, Caroline, and Museum for having me. Thank you to those who dialed in this evening. Let's get right to it. Well, I'm very excited to tell you about the newest acquisition at the Curtis Museum. We're going to be talking today about the CV2 cargo air vehicle designed by Boeing in around 2017. It was capable of carrying up to 500 pounds. And our claim to fame is as the first remotely piloted large electric vertical takeoff and landing aircraft to be flown in support of commercial operation in the United States. So when you read that, you're going to wonder why the Curtis Museum. What does this have to do with Glenn Curtis and Glenn Curtis's contribution to aviation? And you'll also say, well, if I look at this picture here, which is a publicly released image, this is one of the most unique looking aircraft I've ever seen. First of all, it doesn't look aerodynamic at all. I can see like a bunch of like wires and stuff sticking out and tons of propellers. So this is truly a unique aircraft and a unique circumstance that ended up in the museum. I'm super excited to be speaking with you today because for the first time, Boeing is releasing new pictures and videos and stories about this aircraft in support of this exhibit. So some of the images and videos you're going to see today, you'll be the first people outside the Boeing company to ever have seen. And I hope that you'll be able to join us this summer at the Curtis Museum when we put together the permanent exhibit. So with that, let's start to explore this overlap between Curtis and Boeing, as well as what is this concept of rapid iteration, as our title of the presentation tonight suggests. So vertical lift is coming to the Curtis Museum. Here we've got 2 images of testing in vertical lift that were taken 110 years apart. So it's pretty remarkable that in the history of aviation, we've been doing vertical lift in the United States for over 110 years now. On the left side, we'll be talking about this 1908, we'll call it a helicopter, but it maybe not quite meets the definition of helicopter that Curtis and contemporary John Newton Williams were working on in Hammondsport at the time. And on the right, we have that picture of the CV2 vehicle. Similarly, we've got some gentlemen standing around working on it as to prepare it for flight. And you can see that these things look relatively different. Certainly the technology, we can agree, has advanced in 110 years. So if we start our story in time to the early 1900s, those that will be familiar with the Curtis Museum and Curtis's legacy as well will be more knowledgeable than I about the AEA. But we have to give them a little slide here to set the tone. So the Aerial Experiment Association collaborated from 1907 to 1909-ish, and in that relatively 2-year time period, produced many different aircraft in quick succession. You'll see the group there on the left, including Kurt, as well as Alexander Graham Bell, probably the 2 most famous members. And in that 2-year span, introduced some key technical innovations, notably wingtips and the tricycle landing gear, although the museum will be quick to tell you, like many early firsts in aviation, it is contentious as to who actually invented some of those things. And 2 years is a remarkably short length of time to be really expanding the boundaries of aeronautical sciences. And if we really zoom in on even just 1908, we could talk about the aerodrome, of which, there's a great deal of history at the museum. We can see just from left to right in this period of a few months how much these designs were changing. But one thing you'll also notice as the period from left to right is by modern standards of success, we might not actually call these particularly successful inventions. The number 1 Red Wing crashed beyond repair on its second flight. So more or less one and done. With that, the team went and rebuilt the White Wing, version number 2. 5 days after the first flight, crashed beyond repair. Aerodrome number 3, for which we at least have a nice picture of it actually in the air, flew successfully 3 times before attempting to take off from the water and sink. So the team said, 3 times is enough. Let's try to make this into a seaplane, and was unsuccessful on the first try. So certainly we're changing things a lot. We're exploring a lot, but it doesn't really quite appear successful. And if we zoom out a little bit from 1908, what's less known about Curtiss at the time is while he was supporting the AEA and these airplanes, he was also supporting vertical lift with contemporary John Newton Williams. So John Newton Williams, you'll see on the left side here, was experimenting with this idea of rotating wings, we would call those blades, and having counter-rotating ones to lift something vertically in the air. The idea of vertical lift dating at least back to Da Vinci. But in these early model tests around 1904 and 1905, his design showed a lot of promise, so much so that the AEA invited him to Hammondsport and said, we'd like to collaborate. We think what you need is a Curtiss engine. Curtiss, with his expertise in motorcycles, was paving the way with lightweight engines. And with vertical lift, the science was well known at the time as it is today, how critical the weight is of the engine, even more so than an airplane, because with an airplane, you can put a very heavy engine on. As long as you go fast enough, it will still take off. Not true for a helicopter or vertical lift aircraft, because you do not have the speed of the air during takeoff to actually help you. So 1908, Curtiss comes to town, right in the thick of the aerodrome experiments we talked about on the previous slide. Sorry, I said Curtiss, meant Williams. And successfully, they were able to actually install Curtiss's V8 engine into this helicopter design and lift a man, Byron Brown, allegedly up to 3 feet off the ground. With that, the team basically parted ways from Williams, and he went on to do many more of these. You'll see an image on the right there of him in 1912 and something that looks a little bit more practical and closer to a modern helicopter. So it was really a short period in time that these teams collaborated. But this is considered the first vertical lift in the United States that actually picked a person off the ground. So a lot going on, as we know, in Hammondsport around 1908. And just like in the previous slide, a lot of iteration. Going from 1904 to 1912 is only a period of 8 years. That would be remarkable by today's standards. To go from a small model, kind of the equivalent of what you might call like a hobby toy, to something that was flying people. And so we look at the environment that Curtiss, Williams, and the AEA were testing in the early 1900s and say, could we replicate such an environment in the 21st century? And if you ask yourself that question, what you'll see is there are a lot of new hurdles that Curtiss and those around him did not have to deal with when they were testing airplanes and helicopters in the early 1900s. Biggest hurdles that you might encounter if you were trying to repeat these experiments: FAA aircraft certification and pilot's licensing began around 1926. So controlling both the aircraft itself and the person flying it, very similar to how motor vehicles are licensed today. Additionally, electronics, both the hardware and software, became pretty important to any sort of modern aviation. The earliest records that I could quickly find of those types of computer technologies were all the way as far back as 1930, which I think is also pretty impressive, but adds a whole nother dimension to how you actually build up an airplane or helicopter. And modern safety regulations, both what we think about protecting people as well as the aircraft, would have been cited around the mid-1930s. Here on the bottom left, another aircraft I worked on, the 777X, has been in design and testing for probably 20 years for a single airplane. And so compared to what we previously saw, it would appear that the challenges of these modern both regulations and also just the environment we adapt and work in would prohibit modern rapid iteration of aircraft design, which is basically the end of my presentation, right? Well, there might be one exception to this rule, and that would be the Boeing cargo air vehicle. So very similarly, it's a period about 2 years, just like we looked at with the aerodromes. We have a number of different iterations, certainly very similar, but a little bit different each time in progressing technology. However, also like the aerodromes, if we look at these aircraft, it doesn't seem like they were particularly practical or successful. We have CV1 number 1, struggled to fly due to controllability issues and was retired. Think that the longest flight time ever achieved was around 13 seconds. About a year later, we have CV2 number 1, was flown indoors over a period of weeks and never received a full FAA certification to be flown outside. This was updated. Eventually, we got to CV2 number 4, which was lost in an accident after a number of flights, just like Curtis. And you say to yourself, okay, so clearly the takeaway from this presentation is now that rapid iteration is a great way to get nowhere, right? What practically comes of this? So this is the part where Andre and I practiced the presentation. We had to try to exit from PowerPoint, see if we could pull up a YouTube video that says, well, where do we actually get to? So this link will be, we'll put this on the Curtis website. This is out on YouTube right now. And certainly you're going, whoa, we've got some Star Wars and some Disneyland. We got something flying. And if you squint closely enough, you'll see CV2 aircrafts holding these X-Wing models flying over Disney World in Florida. And when we introduced the presentation, we talked about the first remotely piloted vehicle in support of commercial operations. I think a more interesting way to say that is in support of the Walt Disney Company. It was a pretty exciting event. We flew for about 3 or 4 nights right here in Disney World. So I'm going to click back into the slide here. See. Someone tell me if this does not share back to where we were. Hoping it does. Silence is goodness. So little screenshot from the YouTube presentation. So CV2 number 6 and number 8, talking about a lot of iterations now if we're up to a number 8, is this first remotely piloted eVTOL in support of commercial operations. And so what do these things really have in common? You'll actually see here quite a bit in common between what I'll call the Curtis ethos and the cargo air vehicle program. Part of the reason that Curtis was rapidly iterating was to win a prize that was to be given to the first person who could publicly fly over 1 kilometer in an aircraft in the United States. This prize was put out famously to try to get the Wright brothers to famously demonstrate what they were keeping secret, which was their design of their airplane. And so even though the public wanted to see the Wright brothers, Curtis kind of snuck in there and successfully took the prize and was able to demonstrate. And similarly, the purpose of the CAV rapid iteration was to have something that could be done in public demonstration. You can see here that funky shape we talked about in the beginning was designed so that you could mount this X-Wing looking thing and really make it look like a Star Wars vehicle in real life. Rapid iteration of public demonstration is a common theme throughout aviation history, and it just comes down to dollars and cents. When you can demonstrate something publicly, people want to invest in your ideas and your companies. And that was certainly true in Curtis's time as well as the modern era. And so despite what we may have conjectured earlier in our presentation, rapid iteration remains from both the 20th century into the 21st century. The cargo air vehicle would be a really pinnacle example, and it shows that a very similar timeline for iterating to align with what Curtis and Williams were doing with vertical lift. With that being said, why does this aircraft belong in the Curtis Museum? There's more than just rapid iteration. We can actually see some common themes between what Williams and Curtis were doing with their vertical lift and that of the Boeing cargo air vehicle. We'll take some time now to delve into some of those similar technologies. So one that would be very counterintuitive is tethered flight, which means tying the thing you're trying to fly to the ground. This doesn't work for airplanes, but it's a very practical way of testing helicopters to make sure that they only go as high as you want them to when you're just starting out. This flight performed with Byron Brown in the aircraft in Hammondsport was tethered to the ground, and written reports talk about the fact that it flew as far as the ropes would go, about 3 feet off the ground. Similarly, the aircraft that is now at the Curtis Museum was tethered to the ground, In a very unique and novel way, there's actually a patent here. It was flown more like a kite than a helicopter. So the aircraft would be let out like you would let out a kite, and would kind of float around in the air. And when you were done flying it, you would pull it back in. Let's try to actually see what that looks like in practice. So this is the first flight of that CV2 vehicle design, CV2 number 1, that is currently on display at Curtiss. You can see, although it's probably very hard to see, this cable that stretches to the left side of the screen, that's like the kite cable, actually letting the aircraft out and up into the air, about 1.5 feet off the ground. So very similar to what was done in 1908 in Hammondsport. Some other interesting details, you can actually see a little orange piece of masking tape to let the operator of the winch, the kite string, if you will, easily see how far the aircraft was off the ground, so that you didn't let it go too far, just as what Curtiss and Williams did. Flight here lasts about 30 seconds, comes back down. So very similar technology, and remarkable in the fact that we really haven't come that far in 110 years, and maybe even since at least Ben Franklin's time with kites. The next interesting and again counterintuitive technology that both Curtiss, Williams, and Boeing were using as part of rapid iteration, something called factory power. We might call it grid power in the modern era. I mentioned to you earlier how challenging the weight of motors is in vertical lift aircraft, even more so than airplanes. And so as part of designing the aircraft, typically the motor or the propulsive force is one of the last things that's ready to be tested. As part of Williams trying to prove that his machine could actually lift people off the ground, he tested the apparatus with factory power, using belts and suspenders quite literally to drive his rotors in a little test setup that you see here. And he measured the thrust. And in doing so, he was able to show that even though he didn't have the engine, if an engine existed that produced enough thrust, his device in this current size could lift a person. It could lift about 540 pounds, which was in excess of what you would need for the person and the actual machine itself. Similarly, with the Boeing CV2 aircraft, the concept of electric vertol is relatively new. It became a big fad in the 2010s as a way to combine sustainable aviation as well as urban transport. And in Boeing's attempt to put this aircraft together, the last piece that was ready was the batteries. And so as you can see, similar to before, we've got the cable here that's like the kite cable with the little orange sticky note, and a lot of bigger cables that are actually connected to grid power. So instead of having batteries in the aircraft, this is live power, much bigger than your household, about 400 volts power supply to drive these 12 electric motors, but similarly showed that once the batteries were ready, if the batteries could produce the same power, this aircraft would be capable of flying, which it did a number of months later. Automatic stability is another interesting concept that was common to both the early 1900s and today, particularly with vertical lift aircraft. Williams recognized that because of the unique dynamics of a helicopter, even more so than an airplane, it needed to be specifically designed to be automatically stable. And they utilized a low center of gravity so that it would be self-balancing. This is true of many different aircraft today. But similarly, if you look at this aircraft, and we just saw the video, it had that sort of automatic stability. From our vantage point, we could see it kind of waddle to the left and right, much like a kite in the air, but it would always bring itself back up to the top. This is accomplished in the modern era by more than what it was in 1908. There's both the software and hardware components. So with the 12 rotors that you see in the video, there's also a gyroscopic sensor that is measuring the pitch, roll, and in some ways yaw attitudes, and always bringing the vehicle back upright. Earlier, we talked about how software and hardware is a much bigger component of aviation and aircraft design than it was 20, 40, or 60 years ago. And that was very much on display as part of the cargo air vehicle program. But perhaps most fundamentally to these two designs is this idea of coaxial counter-rotating rotors. If on your way home today, you saw a helicopter in the air. It almost definitely did not have coaxial counter-rotating rotors. However, it's perhaps the most fundamental way to lay out rotors. And the reason for that is if the two rotors are on top of each other, spinning in equal opposite directions, the actual craft underneath will not spin. In addition to that, all of the thrust is putting in the vertical direction. And so Williams recognized this early on with his Curtiss engine down here in the middle. And even as early as 1904, his design showed coaxial counter-rotating rotors. There's an excerpt here from a patent that Williams would later publish that specifically calls this out as one of the enabling technologies that actually lifts his machine off the ground. Similarly, the cargo air vehicle with its 12 rotors and 6 stacked on 6 utilized this coaxial counter-rotating piece. When you combine the various spin directions and you put all 12, this was another sort of unique way that this could be accomplished. And so similarly, Boeing engineers had an equivalent patent. So again, 100+ years apart, not only do we see the coaxial counter-rotating rotor, but the patents as well. To better actually visualize that, I included some images here at the bottom. Here's something that's very different than Williams and Curtiss's time, and that's wind tunnel testing. To ensure that we could produce the thrust necessary to lift off the ground, we tested the aircraft not just the way that Williams did with factory power, but we actually tested individual rotors and propellers in a wind tunnel at Boeing's Philadelphia facility. I bring these pictures to actually show some more detail about the counter-rotating nature. You can see this picture on the right side better shows that the blades are not quite aligned and that they can spin in opposite directions, as well as sort of some of the pictures that include the hubs of the blades together and the motors themselves, which we'll talk about a little bit more coming up. This particular facility at Boeing Philadelphia can turn on the wind, so to speak, in a wind tunnel up to almost 300 miles per hour. So this can test helicopters, but everything up to airplanes as well, which is something that I'm sure that Curtiss would have been quite jealous of cold days out on Cayuga Lake. We also know that Curtiss was obsessed with making his engines better, something that Williams would certainly appreciate after his invention was only made possible with a Curtiss V8 engine. Increasing thrust is everybody's dream in aviation. Williams was able to benefit from this Curtiss engine. And on the CAV program, we similarly had a challenge. What you'll see juxtaposing the two images on the right is that the motors, and I'm going to try to point with my cursor, they're silver and in the middle, and then there's these black pieces. Those are the motors, kind of looks like an Oreo. On the upper image, they're black. And on the lower image, the colors are reversed. Now it's the silver outside and the black on the inside. Two different versions of the motor. The upper version was an existing aviation hobby motor that was available for purchase. The bottom ones were designed specifically for Boeing, specifically for the cargo air vehicle program, to produce the amount of thrust that was needed to accomplish our goals. And so think back a moment to the video we saw of the indoor tethered test. Certainly we got off the ground. I think no one would dispute that that was flying, but it wasn't exactly going very far, very fast, and it didn't have to deal with an environment. So what does upgrading the motors and the propellers actually get you? Well, this is that video of CV number 4, a couple months after the item we just saw. I'm gonna make sure we're muted here. This video is a little bit long, so I'm gonna talk it through as we go. But I hope that you'll see that we start out untethered in a hover here. We're zoomed out at this point, so you can't quite see, but I promise that it was those newer black motors shown. And we rotate from our takeoff sort of orientation before climbing up to a higher altitude. We're outdoors here in Texas in the summer of 2019, and we now are building up some forward speed. As part of helicopter testing, knowing that amount of wind is very important. So the thing that's actually in the foreground of your screen here is a LiDAR sensor checking the wind speeds for us. We're at an actual airfield, in fact, a retired naval air station with a full runway and hangar to use for testing. And now our aircraft is accelerating out and climbing. We have just about hit 40 miles an hour, which is vastly different than the aircraft you saw earlier, even though they were almost the same. Changes to engines, propellers, and software is enough to go from 0 miles an hour indoors to 40 miles an hour outside. Walking through what you're seeing here, the aircraft climbs and descends as part of a check that it has enough power to do so. And now we do something in flight test called a steady heading side slip, where we intentionally turn the heading to not match the direction we're going to sort of mimic a sideward wind. This is to check out that we remain controllable during that sideward wind. With those batteries that I mentioned earlier, the maximum time aloft achieved by the cargo air vehicle was about 4 minutes. The limiting factor was not the thrust or the batteries, it was actually the battery temperature of the battery design. And here you can see that we whipped around quite rapidly in a bank turn, still going at about 30 to 35 miles per hour. Now our cameraman loses us briefly, but gets back. And with that turn completed, as we're coming back to our takeoff position, we'll initiate a second climb with a more rapid vertical velocity than our first one, since now we're basically increasing aggressiveness as we go through the flight program. So this is, again, much different looking than where we were just 6 months back in technology compared to our first video. The aircraft configuration that you're seeing here with the updated propellers and motors is the one that's currently on display at Curtiss. Though it's not this particular vehicle specifically, it's the vehicle from the first video you saw, but with the more modern motors and propellers. So we've got a little bit of a turn here back to our landing location. One other interesting thing about this test aircraft is it does not have eyes. It doesn't know where the ground is other than a GPS. If you've driven around with a GPS in your car, you know, sometimes they like to jump around and not really know where they're at. And so to ensure a successful landing, the vehicle actually hovers above the landing area and then initiates a slow descent, something that is different than a lot of helicopters you would see out and about in Hammondsport, New York. So I hope you enjoyed seeing that we went much faster even than the Disney video we started the presentation with those Disney X-Wing shots from YouTube. The aircraft was only going about 12 miles an hour. Tried to use some good visual effects to make it look better. This was much more aggressive intentionally, because when you're testing something before showing the public, you tend to be more aggressive so you're confident in your public demonstration. I'm going to click over to the next slide. Just like we talked about early on, things can go wrong. We talked about with the aerodrome and some of the issues that they had with a couple of crashes early on. Vertical lift was no different in 1908. Williams and Curtiss particularly struggled with the clutch. You can even see some smoke and fume types things coming out in this black and white picture on the left-hand side. Similarly, in the modern era, things can go wrong. This image on the right was generated with data taken just 4 days after the video we just saw. The video looked awesome, right? Well, that's not quite the whole story. Interestingly enough, it wasn't the aircraft that really had a problem. It was that wind sensor that we pointed to in the video. You can look up this accident investigation report from the NTSB, our friends at the FAA, that said that the wind speed was inaccurately measured. The graphic on the bottom is definitely something that Williams and Curtiss would have loved to have. Shows the trajectory that the aircraft actually took versus the trajectory it intended to take. And with this larger amount of wind, it was blown too far off of its desired course. And as part of our safety regulatory software, the aircraft would actually cut power if it was blown too far from where it intended to be. So we talked about that being one of the interesting new features of flight tests in the 21st century. And in this case, it made for an interesting investigation. But we were able to produce some of these trajectories using our tools and technology, in particular our flight simulator, to show that if we had actually known what the winds were, we would have predicted the same thing would have happened, which is a pretty remarkable advancement from the early 1900s aviation. So in summary, I think that why does this aircraft belong at Curtiss, where you can see it right now? Here's a picture right there next to the Curtiss America reproduction. Historical firsts prepare us for the future. We know now that Curtiss and the AEA and their aerodromes contributed technologies that we see in airplanes every day. And although you may not have known it before this particular presentation, the work that Williams and Curtiss were doing in 1908 contributed to vertical lift technologies like those shown on this cargo air vehicle platform. In a similar way, the firsts demonstrated by this cargo air vehicle, including its unique arrangement of propellers and its electric propulsion coupled with autonomy, prepare us for what is to come in the 21st century. Perhaps the vision of air taxi is not that far off. And in 50 years, we will be looking back at this particular moment in the 2010s as being one of the enablers of that. So I do hope that you'll come to the Curtiss Museum this summer, starting in late June, to see this full exhibit. We'll have much more information about the cargo air vehicle program, as well as the Curtiss Williams 1908 vertical lift on display permanently. And there will be additional few surprises. If you enjoyed some of the videos and pictures that were shown for the first time today, there will be more surprises to come this summer. So we do hope that you'll make it to the Curtiss Museum to see this exhibit. With that, I've got sort of an outro slide. Just going to play this video again. This is the same first video we saw of that tethered flight, just with a different view, showing some of the team members that made this flight possible. This was a GoPro 360 view with folks on the left-hand side here. On the right side, we have our very important fire department in case anything goes wrong, and me. So if you were looking for the part of the presentation where I told you what my credibility was to talk to this today, we mentioned the flying a kite. Someone must have thought that because my name is Ben, just like Ben Franklin, I was credible enough to be the kite flyer. And so I'm the one operating the kite cable over here on the right side. You can actually see I keep lifting up my left hand in the video, and that's because the microphone button to talk to the rest of the team was on the left ear. And so I'm actually checking with the test team to say, are we good to take off? Are we good to land and all that? So I hope you enjoyed this presentation, learning a little bit more about flight test and vertical lift through the past century or so. Happy to take any questions now. And I do hope you'll join us on June 28th for the opening of this exhibit, or sometime after at the Curtiss Museum to see the vertical lift exhibit. Thank you very much.